Okay, so warm welcome to the talk before the break in the afternoon. I'm going to talk about worst practices and welcome you to the dark side. So, not sure, I guess most of you have listened to the talk of Chris previously, right? So I'm going to tell you the truth on that. I worked for Neo for more than 3 years now as a field engineer, and yeah, in that period you see all kinds of things going wrong. So, going wrong is a good point. So this talk is mainly about self-therapy of myself. So just to tell a little bit of stories on what went wrong. I will also tell you some anecdotes, but don't be scared, I don't mention any customer names today. This talk was inspired by one of the talks at the Grails conference years ago by Bert Beckwith, where he's taken also the Grails worst practices. And he took two positions on the stage. So one position when you tell people how not to do it, and the other one if you need to put some context on that. And I try to fit with that pattern as well, but I'm not sure if I managed to synchronize my feet with my voice. Yeah, let's get started. So the first thing to make really sure that you totally mess up your project from the very first day is, yeah, choose a mission-critical project in your company. And try to get as much management attention as you can get. That makes a lot of sense. So if you're a bank, probably exchange your backend system. That's fun. Once you identified that cool project, you should probably avoid to have anyone in the team who understands what you're doing. So we have great documentation, so you can read that from page 1 to page n, and you know all the fancy stuff, and you're smart, so you don't need external help here. Since you've now chosen to run Neo4j as your new toy, you really like it, it's a cool piece of software, it makes fun, so we can completely work for fun. We don't have to care about requirements from the business side, we just do cool stuff. That gives a lot of attention from the upper levels, right? Also, try to avoid training at all. So there are the guys from Neo Technology trying to sell training. Don't go there. You will have peeps like myself educating the bad things. So skip that. And even if you try to get rid of these advices that I just mentioned, don't ask anyone. Lock the door, plug the wires, and work on your own. This is distraction-free, right? And also ignore the learning curve. This is a nice chart drawn by my colleague Mark Needham. So there is, at the beginning, you will find it a cool tool. Then there will be a ramp-up period where it gets hard, because these are all the things you have to explore yourself, which we don't tell you in the training, and which you don't normally get in the talks here. And once you reach the bottom here, it gets easier and easier. And at the end, you're in an area where all the things look like graphs. Once you're there, it's really good. But it's a little bit hard way to get there sometimes. Yeah, on data modeling, I think we have seen that already a lot. So in Graph World, the whiteboard is the real model, so you don't have to change between relational, between a logical model and physical model. So that is how we work in the graph. And graphs are schemaless. So, well, that basically means you shouldn't care about design at all, because there's no schema, no design, wonderful world. Creating these kind of reference data models where you sit together with your colleagues, draw some things on a whiteboard, that is really for wimps. The best thing is that every developer in the team has its own graph model. You shouldn't agree on a common thing here, because this is endless discussions. You know, Neo4j is coming from Sweden, and in Sweden they have a kind of habit of getting everything in consensus. So they discuss a lot, even when they're on the fire. There is a nice video where the Swedish army is under fire, and they start first a discussion what they do, and ages later, one takes the rifle and shoots back. So that's probably a good approach. And even if you ignored my advice on doing a nice graph model, don't document that. Nowhere. It should be kept secret. And even people tell you here about graph gists for documenting. Everyone can read them. Skip that. And you shouldn't care about naming conventions. And there's a good story from one of the customers in Germany. So we have a very traditional, large-scale German enterprise. And since they're traditional, they have the mandate that everything should be written in German there, even if the project team is an international team from every kind of country in the world. So there was the one guy in the team who understands German. He has only the task to translate the requirements into English for the others and writes the documentation in German back. And since everything should be in German, they also choose to write the relationship types, the labels, and all that stuff in German letters. So you have our nice umlauts there. Neo can handle that very nicely because we are UTF-8 compliant here. But if you run a query on a client that runs English locale, and you run the same query on a machine that runs German locale, you get different results. Well, it's obvious if you know that, but if you don't know that, you can spend days and days debugging that. So use your crappy letters here. Also, having columns in relationship types can make Cypher statements really nice readable. So obfuscating Cypher is a good idea. Yeah, I mentioned the last point already. So basically, to sum up, you should use your relational skills that you have learned over the last 20, 30 years and apply them to your graph database. And if you hit that screw hard enough, it will make its way through the piece of wood, right? But of course, you can use another tool and make this in an elegant, more convenient way. So you need to apply. So the hardest thing in applying to graph databases is getting rid of your relational thinking. Yeah, in terms of data modeling, you should be an extrovist. So consider here a model. We have a person that has two addresses. So either you go on the left-hand side. I see just my lovely colleague Peter is sending me some messages. Wonderful, thank you. So either you put everything in one node, so having a huge number of properties on that node, that is good, that keeps the graph simple, so you have only a few nodes. Or you can go the other way around and say, well, every property should be a node on its own, so we basically can limit us down to having only one single property on each node. Yeah, both approaches are really nice to mess up your graph. Of course, the right way to model that kind of case is in the middle. So everything that is a thing on its own should be a node. So the person, of course, maybe their address should be a node on its own. But then you should make use of the properties to have the attributes of that entity. And in the same way, we need to be extremists on deciding what should be a node or not. We should be extremists in choosing relationship types. So if you look on the left-hand side, you see a wonderful generic graph model where you just have one relationship type, which is connected to. And what's the semantics of that? Well, we don't know. But as said, we had no schema. Wonderful. The other approach is on the right side, that you scope every relationship with an instance. So you end up basically having a single relationship per relationship type. Be careful, we only support 65K different relationship types. So that limits the size of your database. That keeps it fast. Yeah, and one general advice, you should use Neo4j as a Blobstore. As you might have learned, we do support byte type properties, and we do support arrays of primitives. So byte array, wow. That opens up the possibility to store gigabytes in a property value. Honestly, the reason for that is because we organize the properties in blocks. So all the properties go at the end of the day in one file. And if it's a huge property, it's cluttered all over the file, and it takes a very long time to read that. So using blob data in Neo4j is one of the very few real anti-patterns for graph databases, in my opinion. So if you have to deal with blob data, choose an appropriate store for that, and store in Neo4j the URL that points you to the binary data. Yeah, also a very common thing I see in the wild is hiding aspects. So here in the top, you see I'm modeling the country as a property of the person. And later on we decide we want to find all the people, all my friends in UK. So the query at the top will basically, oh, sorry, I should stay on the other side. So the query in the top basically gives you, traverses both nodes and then filters that out. Whereas if you do a refactoring and you treat country as a concept on its own, you can have a more efficient query, so you don't need to touch the Michael node here. So that is, of course, in a small data set, it doesn't make any difference, but if you go a large data set, that can be really hit you hard. So that means basically your query patterns influence the way you model data, which is different from relational databases. There you just have a static view on how your structure is, and then that's the model. You completely disregard query time with that. In Graph World, you consider the static structure of how the world is related, and you put the query patterns into the consideration when deciding on the data model. Yeah, node IDs. Who of you in the room has already used the method getID on a node? Okay, who has experienced some trouble with that? Okay, thank you. So honestly, adding getID on the node interface was one of the worst design decisions ever in Neo4j. That have never been released to the public. My friend Andres smiles, so he knows how it feels when you have to catch back some piece that is out. So what I need to explain with the node IDs, the node IDs do have a semantic. So the node ID gives you the offset of that node or relationship within the store file. So if you delete that node, and you might have a reference in a third-party database, like let's assume Mongo points to that node and you just store the node in Mongo, you delete that node, you forget about the reference in Mongo, node has been deleted, you create a new node, well, there's a free space here in the node file, so let's allocate that. So the new node has the same ID as the previously deleted one, and the dangling reference now points to something semantically completely different. That's major fuck-up. Yeah, there is, of course, a solution for that. So you basically store a UUID property instead of relying on the semantic-driven ID, and you put an index on that, and then you reference the UUID. And then even if you delete something and you forget about the reference, it points to nowhere, so you get an error message, okay, you know there's something wrong, but you haven't really messed up things. What do we have here? Oh, indexing, one of my favorite topics, yeah. To make life easy for you, we provide many ways of indexing. So you should focus on using the legacy indexes. They're really powerful. You have fine-grained control. You can set up analyzers in anything you need. You can write to them. You can even write stuff to the index that is not in the graph, which is also a good thing. Seriously? You should always use, when possible, the schema indexes. They have been added in version 2.0, and now with the 2.3 version, there is a major improvement for them. You can now do prefix queries based on indexes. You can do range queries, and Andres, I hope we'll see more in the future on that. So the long-term goal is that we don't need the legacy indexes anymore. And there's a story about that. So when we first released 2.0, there was the opinion that we pretty fast cover all the functionality of the legacy indexes into the schema indexes. That's why we said, okay, well, now let's claim this is legacy. But there are cases where you still need legacy indexes. So for example, if you want to do full text indexing today, you can't do that with schema indexes, sorry. But we chosen to make it a little bit hard to use for you, so if it's hard to use, it should be, it's good. Yeah, one strict advice here is you should index everything. Basically, good pattern is if you create a label, consider all the properties that label should have, and put everything in an index. You might use that index one day. And we have seen an example where there was a graph store of, I think, less than a gigabyte, and the index folder was 150 gigabytes. And they just indexed everything. Indexing, it basically means you trade write performance for read performance. So you invest more on the writes, but you gain on the reads. If you have an index that you never use in a query, well, your CPU is getting a little bit warmer, the disks get a little bit fuller, and probably, since your system is smaller, my sales colleagues happily sell you another instance for that, for performance reasons. So do that. Yeah, a few words on Cypher. I've seen explain and profile multiple times this day. Don't use it. It just confuses you. These query plans look really ugly. You should also, when speaking of relationship types, not use the colon in front of them. Anyone understand that joke? Some do? Okay. For the others, I explain afterwards. A general good recipe in Cypher is try to collect as much as you can in the match part and filter out that huge amount of data in the where part. That makes sure the CPU gets not cold. Also, try to feature property filtering instead of using more granular relationship types, because reading properties is fun. If the CPU doesn't have to do that much, it's boring. One really good tip is if you have a result of multi-million rows, use order by and distinct on those. This will give you the good impression on how much memory you have. The word with is evil. Don't use that. Point. And another good idea is you should try to write complex business logic in Cypher. That's exactly what the language was designed for, just as SQL. Oh, did I skip something here? Yeah, I missed the point of Cartesian products, right? So they're really great because you have much more data to traverse through. Luckily, the recent version 2.3 will indicate an exclamation mark when you type a Cartesian product in the browser. So we know that users tend to do that. It's a pretty common thing for relational world. When you move over, that you do this wrong, and that is one of the things we show you now in the browser. Yeah. Everyone, when you get familiar with the merge statement, you have the impression that it guarantees uniqueness. It doesn't. Just try the shell command on the bottom, and you will end up with having, so what this statement, what this shell call basically does, you run 100 concurrent requests on merging a person called John into your graph. I should have changed that slide because John just left the company. But after that statement, you will end up having multiple Johns in the database, even if merge gives you the impression of uniqueness. If you really want a uniqueness, use the unique constraint. That's why we have it. Also some fuck-ups with load CSV. Andres, sorry, I got hit by that so often, so I really need to bitch on that. So, as you might know, if you have a large CSV file, there is using periodic commit, which gives you the impression that for every 1,000 or 10,000 rows, a new transaction is opened. That's the theory. If you try that statement in version 2.2, or if you do an explain on that, you will see in the query plan there is the word eager. And every time you see eager, that means periodic commit will not work for you. This was really bad in 2.1. It has improved in 2.2. And even that statement does periodic commit nicely in 2.3. So we are getting rid of more and more cases where this can happen. But whenever you come into a problem with load CSV, try to analyze the statement and check for eager pipe. If you find eager there, try to get around it. There's some blog posts from my colleague Mark and some other information on Stack Overflow on this. But that can hit you really hard. Another nice thing in Cypher is we can deal with dynamic relationship types. Consider that CSV fragment on the right. So we want to connect two people with a dynamic relationship type with each other. Unfortunately, well, something that is hard should be hard to write. So we have this nice syntax with the for each and case when notation to mimic dynamic types. So I see some question marks in the air here. What that thing does is basically, with the case when, we create a collection that has either one element or is empty. And with the for each loop, we iterate over that thing. So if the condition is true, we iterate once over that. If the condition is false, we iterate 0 times over that. That's because we don't have an if then else. Yeah, unmanaged extensions. I think Chris just talked in this room a little bit about that. So a good practice up till version 2.1 was to spin up a new execution engine for each request. I've seen that in dozens of customer projects. Yeah, we understand that this is a problem, so since 2.2, you have just graphdatabase.execute, so you cannot really make that fault anymore. Execution engine still exists, but it's deprecated, so you will probably realize that you're doing something wrong when doing that. You should also, when using the extensions, ignore the principles of REST. Short story from one of the customers in Germany again. So they decided to do a lot of stuff in extensions, and they grabbed one example from the web, which was a post request. They said, oh, this works nicely, so let's copy paste that 100 times and do, for each of our use case, we use that kind of strategy. Unfortunately, they ended up to using post for read requests. Well, that's getting fun if you try to put a cache in front of that. So if you would have used REST the right way by using get method here, Squid can probably cache that. Oh, sorry, I should have been on the other side here. Yeah, also a good thing is you should not, if your code involves additional dependencies that are not part of Neo4j itself, you should not put them in the plugins folder. You will see that probably with some class not found or class def not whatever error. And one thing you see in a lot of examples on the web is that people tend to return this response class directly from their unmanaged extensions. In my opinion, this is against the design principles of JAX-RS. So there you should return your classes, your DTOs, and leave it up to provider classes to transfer that into JSON or XML or whatever response you want. I found this library at the bottom very useful for rendering your custom DTO classes. But it helps a lot if you have that on the class path. Yeah, on testing. Who of you is working test-driven? Okay, few hands, few more hands. Who has actually lied? Okay. Yeah, don't do this testing. We all learned that testing is hard, and just skip that. Also, if you decide to do testing, against my advice, skip those tools like Test Graph Database Factory and the Neo4j harness tool that ships the Neo4j rule for spinning up a server directly. You should also, when doing testing, scatter your reference graph that you use for your tests all over your code base, because then a single design change means that you have to change that in 1,000 places. That keeps you busy, and well, as a developer, we don't want to go home at 5. And of course, forget about all that stuff from the ecosystem. So there's the nice GraphConnect tool. There is Neode from my colleague Ian. The Neo4j Spock extension is a shameless self-plug. Anyone using Spock for testing? Okay, it's great, right? Yeah. So if you don't use Spock yet, just take a look at spockframework.org. It's totally independent of Neo4j. Cool stuff. Deployment, yeah, wonderful. Use milestones in production. That's the best advice. You should always grab the freshest snapshot milestone, whatever build, put it on your production machine. We do guarantee upgrades between stable versions. But in general, we do not guarantee that you can upgrade from one milestone to the other or from milestone to the GA version. So we have had multiple customers, well, not yet customers, prospects, who get in panic. Well, we deployed 2.2 milestone, whatever, and now we upgraded, and there's no way to upgrade that. There are some internal tools that can help you with that, but you have been warned now. The release notes are just written for our own entertainment. They're considered write-only documentation. Don't read that. Also, Chris told you that you need to do server tuning and mess around with JVM stuff. Skip that. We're PHP developers. JVM is a black box. That's good. So treat it as a black box. Don't touch it. And yeah, run your production system on Windows. Yeah, personally, I hate Windows. So I don't do anything on Windows, right? But there is up till version, including 2.2, there's a good technical reason as well, because one of the two cache layers, up till version 2.1, sorry, one of the two cache layers was off-heap in Linux and on-heap on Windows systems. So there was no way to cache a large graph on a Windows system in a proper way. So with the current version, that's vanished. So now it's just my personal hate against Windows. And I do have the feeling that Windows memory management is much worse than Linux. So I have a couple of cases where a customer comes and say, well, I'm getting here some POC on that graph. The query takes 25 seconds. And I say, yeah, give me the GraphDB folder. I spin up this version myself, no tuning. And the query time went down on that crappy 3-year-old laptop to 12 seconds. So we already gained 50% by just switching OS. I have no idea why that happens. Maybe someone can explain me the details on that. I don't know that. But I do know Linux and Unix a little bit. Have anyone used the limit command? So if you want to have fun, limit the amount of memory you grant to the Neo4j process to less than you have RAM. You get funny exceptions on that. But fiddling out that as a root cause took me several days. So leave the limits as they are on default. Point. How much time do you have, Alex? 5. Okay, cool. Few words on clustering. So you should not try to understand the concept of clustering. We invested many years implementing that. Not all of our people do know that by heart, so we cannot really assume that you understand the concept as well. Also, a good recipe is running a cluster over subnet boundaries, especially if you go multiple regions. That makes it easy for the NSA because the network traffic in the cluster is not encrypted, so everyone can read that. And you should really take a strong focus to make the GC pauses longer than the cluster timeout. Then you have the lovely effect of the round-robin master switch. Use push factor equals 0, and afterwards complain about branch data. If you use push factor 0, branch data can happen. Point. That's very clear in the documentations, and I have seen several people complaining, well, we have some branch data here, can we resolve that? Well, you have push factor 0, that's expected. And also the logical logs should be kept as a shorter period of time than your hardware SLA. So because if the failed cluster member joins again, he needs to fetch the full data store. That gives a little bit more lights on the switches. Yeah, coming to the end, you should ignore the community. Meetups are really, really boring. So you can go at the end of a long working day, get home, take a beer on your couch, stay isolated, good. Even if you decide not to attend a meetup physically, don't use things like the Google group or Stack Overflow. Even when you decided to use Stack Overflow, ask very silly questions there. You will make it in my top list. I will show you on the next slides. And hide your questions by not tagging them with Neo4j. So, and now I'm going to end up with my top 3 Stack Overflow questions ever. So for Stack Overflow, I think we should thank Michael a lot. So he handles most of the questions there. He's doing an awesome job here. So I think we have the freedom to show 3 really, really interesting questions. I've blacked out the author's name of that question. So don't be afraid if someone of you is in the room here. I probably don't comment much on these, so just read through them. Here, pretty interesting is the comment, the first comment here. That's number 3. My personal number 2 is that one. Yeah, please do attend GraphConnect, dude. And my forever number 1 is going here. And it's not about to make the database faster, it's about making the database very faster. That's very specific. So unless you want to add up in this list, switch on your brain before typing, right? Yeah, and now I'm ending up with the only serious slide on that deck, which is that one. It's a graffiti I've seen in Tel Aviv. Yeah, that's the only serious slide. Thank you for attending. Sorry, microphone is, oh, sorry. Do we have some questions? Okay, thank you.